All right, happy Friday, everybody, and welcome to Data Sharks. We've got Rich, Glenn, and Arkady in the dark. He's actually showing his camera, right? It's just in the dark, right, Arkady?
It is. It is. I'm sitting in a dark room. Just I'm developing some
From
film.
on an undisclosed location in a
Yeah,
bunker deep
in a
in the earth.
bunker, doing some top secret data work.
That's it.
We were
That's it.
actually just
Because we're
talking.
talking. Because the topic of today's conversation is such a sensitive topic, I
Yes,
needed to find a
cost.
secure location
Yeah.
and make sure that it's not traceable.
Yeah, so today we're going to talk about the costs around data projects. So what were they like before? What are they now? What's it like in the negotiation phases? And what are some surprise costs? So we're going to get into all of that. Let's start just chronologically and just say, what were they like in the past versus now? Let's have a little bit of that discussion
Sure.
first. So
Well,
go
I was
back in
saying,
time versus now.
so if I go back 10 years ago, as we would talk about doing data warehouse strategies and planning, it was a lot of cost about capitalization of equipment. So it was a lot of, are we buying net new equipment, which was very often the case. So it was, allocation of space in the data center. What is our cost there? Who's going to maintain this? What size of storage are we looking at? Are we getting super fast storage? I remember that was always the challenge is, as we would be talking with people, they'd say, well, we can get you this storage. And we'd say, that's too slow. We need it to be faster. We need more spindle speeds. If you go back, hard drive days or as SSDs
and you
came
really
online.
paid for a bad decision there. Like
Oh, yeah.
in either direction.
And you got locked in. I can't tell you how many times we would, purchase SAN storage and then either, it was too small and then we'd say we need more and they'd say, well, the way that we bought it, we can't really get you into the next size without making a huge new investment.
Well, it was so big and large and important. There was the cost of time and all the resources that went into the whole mapping out of planning of all of that, right?
Tons of time.
I mean, how many meetings you sit through to plan out what hardware we were going to buy for this project?
And
Exactly.
I always felt like everybody was having that conversation with alligator hands because nobody wanted to exactly say how much the hardware spec would be.
Hear it because it's so difficult to predict. So first of all, we would be in a room, lots of folks on the IT side, some finance folks, and the conversation would be, okay, let's plan out our development environment.
Right.
And then once we finish that, okay, is QA or test double the size? 3 times the size? How big is that environment? And then let's plan out production. And so the first 4 weeks, sometimes longer, of a project would be spent both consulting dollars and internal resource dollars on planning out various environments. And then what do we do for backup? What do we do for DR? What do we do for offsite locations? That, by the way, still goes on today. Those organizations that for some reasons cannot leverage elasticity of the cloud.
Or some of the challenge we always would have, we say we need to have the data warehouse close to where your data is.
Mm-hmm.
And oftentimes that was even a problem because they say, well, where our applications are, we can't put you close to it. And so then we had to talk about, well, what's our cost for a pipe between the two of them that's going to be fast enough so that as we're loading data, we don't become these bottlenecks. I mean, there was so many, and as Arkady said, it could be weeks, if not months, to get this decided. And you always had two sides of the coin that you were battling. Do we get more so that we can grow into it?
Yeah.
And, the finance people and sometimes the IT people would say, well, guys, that's a big investment. Can we do it smaller?
Yeah.
Can we start smaller? And we'd always say, if we need the space, can we? Oh, yeah. And I burned by that one so many times, as we got into it, all of a sudden we say, we want more. Oh, can't.
Yeah, can't. Oh, we don't have the lease is up on our data center, and this is as big as we get.
Yeah,
it's
exactly.
Like,
or the SAN storage changed, or what you want. We don't have. And we would battle. Here's another thing we used to battle all the time is because we would be moving data very fast, and the packet shaping for data movement is very different than all your web apps and things like that.
Yeah.
that we would battle loading problems because we'd say, hey, we need you to change your network packet shaping for our purpose because you're totally constricting us. We need to be able to have a much bigger packet shape. I remember we had one client where we did get the right hardware, high speed things and things like that, and we were so throttled by the network itself. We couldn't load fast enough, and the nature of that data was large enough that the load time was a critical factor. And so we spent months battling with the network guys and they had to put in new switches for us and all these things. So
it'd be interesting to put a number on the amount of change in costs between consulting as well as of course hardware and just that whole maintenance of a data center and all of those things. I don't know what that number is, but there is a tremendous amount of savings from there. And it's difficult to say a blanket number on stuff like this, but it's a lot.
And we've had organizations make huge heroic efforts to try to, identify costs and allocate costs to come to, what is this costing us, or what is the cost here, especially as they're looking to go to the cloud. And it's a very difficult thing, especially if you have sunk costs already. So it's one of those things that you have to kind of look at and say, let's look at what all the moving parts and big picture of cost is, especially how we did it in the past, and realize which of those costs go away.
Yeah.
And a lot of times those are kind of soft costs. I've got people, I'm paying for those people to do that work. And now you're saying I don't need those people to spend their time there. Well, what are they going to have their time doing now?
But it's also cooling. It's power conditioning. It's backup power. It's they're
pipeline usage. How
exactly.
many megabits are we chewing up every hour?
Let's hook up this big ass fan to our data center.
Yeah.
Glenn actually did that once. So.
Yep. And I'm telling you, you laugh that these were things of the past, but they were. I mean, we would battle the silliest things, that would be, impediments to getting done, and meeting SLAs and some of those things, and so lots of people would have to get involved, and so a lot of times when we think about costs, we're not factoring in all of those costs that were really in doing this.
So how does that manifest itself?
That was the day when we were data whales. Now we're data sharks. So we've moved away from some of the crazy baggage that was there.
Absolutely.
So I'm trying to head towards data minnow, but I got a long way to go.
So obviously we can't have compute for free, right? So what is it? What are we worried about now in terms of costs when it comes to the cloud?
So, there are the costs have changed for sure. We're now looking at subscription costs. The benefit is here's one thing I will say about moving to the cloud, especially if you look at something like Snowflake, where we're really paying for what we use, okay, not for, one of the other things is that we'd stand up servers in the 24/7 servers, right? They're always running, whether we're heavily using them or not. As we move to something like a Snowflake, where it's a subscription model, and we're only paying for what we use, and servers are turning up and down as they need to scale out or are not used. Your change is you're paying for usage, and you can really take that into a dollars look. It's not soft dollars where in the old world we'd say, well, we probably want to allocate some of so-and-so's time and some of this cost from the data center and some of these costs, and it was always very soft and hard to come to that. Here, it's very black and white. We know how much we're using. Now, one of the things that often happens, this is the other side of this equation, is we've seen many organizations who were on-premise in a data center having performance problems. We move them to the cloud, and all of a sudden we see utilization go up, not because it's inefficient, but we have people actually using the data because it's now performant.
You mean costs go up?
Well, yeah. So utilization goes up on this side, not because it was, it's the fact that users are actually using it now, and because it's performant, they're saying, wow, I'm not waiting forever to have my reports refresh. I have data more available to me, and those those things.
And and if you think about it, the data center represented a wall.
Yes.
Could not pass the wall. You know, the wall was a spinneroo on your screen. You were not going to get past the spinneroo. But once the spinneroo's gone, then you're actually measuring true demand,
Yes.
the actual demand of your environment. So those costs.
The other thing, and this is, you know, from the finance side of this, so the cost finance, you know, with a lot of these cloud solutions, and I keep going back to Snowflake because that's the one that's the, you know, kind of the big player in this space, especially as it pertains to data, is if we construct it the right way, we can certainly allocate an understanding of who's using it. It can be very clearly identified what groups or what platforms are the heavy users, and you can really, even if you don't do cost allocation to your business users, you certainly can define clearly who's our users, and that makes a big difference in when people are trying to justify having this. You know, who's using it, who's our big consumers. We now can get very clear. You know, what's our cost to load, what's our cost to from a consumption point of view, be able to delineate that. So all of a sudden we're moving into a real true cost model that makes sense, and that we're not got a lot of soft numbers in there that are, you know, always argued about.
Right.
So Arkady, yeah, go ahead.
Sorry, Jared. The other side of this is that all of that infrastructure has a life. So whether it's a 3-year life cycle, and then we've got to do upgrades on hardware. So that's the other big cost of managing these environments, is going through those upgrades. And the upgrades are not easy, because think about it, whether you have 3 environments or 4 environments, you've got to update potentially all 4. You've got patches that you've been doing throughout the years. That has a cost, because you're bringing these systems down, you're going through the upgrades. You've got maintenance that's happening on maybe some of the hardware, but maintenance on all of the software. And this is just infrastructure. We haven't even touched the plumbing and all the other things that are required. And so those costs are quite significant if you look over a 3-year horizon, because again, when you do an upgrade, when you're replacing these things, you need to be able to move data off of the devices you've got them on. You've got RAID, or you've got a SAN. You've got to upgrade either the SAN, you've got to upgrade drives in the SAN. So all of those things take a toll on costs to the organization.
Well, and how many times did we stand up parallel environments when we were doing these upgrades?
That's right.
Because there was such a concern of we can't have loss, we can't have outage, and you know, virtualization of environments certainly came to play and help a lot in that. But still, in many cases, depending on what it was, we would stand up, you know, the old one and the new one, and run them in parallel until we were assured that on the new platform we were all, you know, happy with it. And so
that actually makes me wonder. It makes me wonder whether, even in scenarios, Glenn, where you mentioned that you have more consumption and thus, you know, the amount being paid for the queries is higher, but are they taking or higher than they used to pay for their, you know, their old data warehouse appliance? But is it indeed higher? I mean, are there other things that they're just not even thinking about that they had to that they weren't adding into that number? You know, because
I don't,
just doing
Jared, I don't think
apples.
they're, if you do apples to apples, I don't think they're higher, because here you're paying, so in case of Snowflake, you're not paying for queries, you're paying for time, essentially, that those queries are running. But those queries are running because you're doing something.
Right.
So you know, 10 years ago,
you could put a hard block on it, and then you would be doing true apples to apples, or
well, because you think about it, the old servers were running 24/7.
Yeah.
Whether it was being heavily used or lightly used, they were, you know, you were paying for them to run.
Yeah. Yeah.
And you know, things like Snowflake, where we have the ability for the processing side to stop and start, and we're only charged pretty much by the seconds that they were used. You know, we're now looking at true utilization. You know, we had a query running and we needed it. You know, you point to where the old systems, they were running 24/7, and a lot of times were underpowered, you know, but they were always running. And so all of a sudden, when now you've got environments and we can do things in the cloud much easier, and we're able to satisfy user needs, the numbers of queries, it's probably a better way to look at it, the number of queries because they're being used goes up because people are using it.
So Rich, in this analytics that you built for analyzing Snowflake utilization and whatnot, I'm just out of curiosity, in the clients that have been using this, what are some of the cost areas that, you know, kind of surprise them, or they find out that they're paying way too much for a certain function because they've, you know,
one of the things that we see on a regular basis is not understanding fail-safe and time travel storage. And so everybody gets all excited. Hey, it's time travel. You know, we can, you know, we can go back in time. It's really cool. And so they set all their tables in their database to, you know, 45 days of retention. And then they've got some, and then you take that and you compound that with a change data capture tool or something like that that's doing blind updates. And all of a sudden your time travel storage is, you know, through the roof.
Right.
And people don't realize that. And you know, so there are new, I'll call it, opportunities for us to learn how to manage these environments. But that's one of the really big things. And one of the other things that we're seeing, and we're actually just working on a new release for the tool to allow us to look at query plans for really long running queries. One of the things we're seeing is, you know, excessive credit usage for queries that are running really long because tables are becoming highly fragmented because of blind updates, those types of things.
I see.
And so that, you know, when that takes place, then all of a sudden you've got a query that, instead of opening up, and not to get too technical on the data sharks on a Friday afternoon, but you've got a query that, instead of just looking at a couple of very specific micro partitions to get the data that it needs, it's opening up, you know, thousands and thousands of micro partitions to get a few lines of data. And so your query performance is shot, and you're paying more. Now, the interesting thing is, you know, with Snowflake, you know, when you talk about that your query performance is shot, it might not be that it's something that somebody would say, oh my goodness, this is taking forever for this to come back, but it could be that much faster, and use fewer, you know, fewer credits.
So zooming away from Snowflake for just a second, when it comes to just the overall data to information landscape, are there costs that surprise the business? Like, in other words, are there what's the most surprising cost that the business is like,
one that
I didn't know this was going to cost this much?
That does pop up, and we always are very cognizant of it. So we always ask clients when we're doing this to, you know, where it is in cloud space. Most cloud vendors of space have what they call regions. Okay, so even though you're in AWS, you're in a specific region. And so depending on where we're storing or in our pipeline to get data from where it's coming from to our cloud data source, depending on where those are coming through, a simple mistake of having your cloud database in one region and storage coming in from a different region, you're going to get hit with that inter-region data transfer cost.
I see. And that's that's really the host cloud vendor that
oh yeah, absolutely. But right? that's a cost involved that can surprise people if they're not, you know. And so one of the things we always do when we're planning with clients is we sit down and we say, okay, let's talk about what our data ingestion pipeline looks like. Where is it coming from? And the question we always ask is, we want to make sure that wherever your data is coming from, if this is your predominant source of data, that the cloud data structure side of this is in the exact same region. Okay. So because when you're in a region, you're not getting hit with that cost. It's kind of the back end network of that region moving data around, and they don't hit us for that cost. But if we cross regions, then there is a cost, and it can be significant depending on the volume of data we're talking about.
You see, you cannot cross streams. That movie
You can't
was
cross
accurate.
the streams. That's right. Don't cross the streams.
That's right. It's
Marshmallows, all kinds of crazy things that happen. So.
And this is again one thing we would say about Snowflake is, and I'm going to use Snowflake as an example, but this would apply to any of the cloud data platforms, is there is some planning up front that just, in the data ingestion pipeline and things like that, that a little bit of planning, and it's not like extensive planning like we used to do in the past to try to figure out hardware, but just some good coordination and planning can save you, thousands, if not hundreds of thousands of dollars in costs that you shouldn't have to bear if we just plan it out right.
Yeah, well, especially when you're doing things like loading 4 trillion rows of data.
That's exactly right.
4.051 trillion.
There you go. So that's just we're constantly being introduced to some very, very large. You have a single table with 4 trillion rows. A lot of large deployments, and so being able to make those efficient out of the gate.
Yes.
Is super, super critical, because it does add up cost very quickly if you're pushing the micro partitions to be opened all over the place all the time.
Right. Other costs. Well, I was just say other costs, Jared, that you asked, what are surprise costs? What is costs that surprise people, or that when they get their bill, they go, what just happened? And Rich talked about one of them, which is we're enamored by not fail safe, but by time travel, and we put time travel on all of our tables, and now we can't figure out why our storage costs just progressively goes up like this. The other thing is just understanding what are appropriate sizes for compute. There's often a fallacy that because I have this ability to have mega compute, I should use it. This is a conversation we have with clients all the time. It's kind of a stool with 3 legs. Part of it is, do we have our data structured right for our consumption? So we have performant data. The other is, what is your use case? Yeah. And is your use case sending me lots of little queries or behemoth queries? Okay. And what is your demand of those? So, let's take an example, a BI platform. If you look at most modern BI tools today, when you run a dashboard or you run a report, it tries to segment those queries into smaller query chunks, which is great. That's actually really good for things like Snowflake. And what we want to make sure we do is size our compute so that it easily accommodates those, but we let it scale out versus saying, no, we're going to create great big compute boxes here. Because, once you've spun up a compute box, even if it's on demand, and if your queries are only using 10% of it, okay, that's 90% that you're paying for that you probably didn't need. And so sizing is a real critical thing. And one of the things we do lots of exercises with people around how to right size those for the use case. The nice thing about something like Snowflake is that we can create all those different types of compute usage to meet those demands. So we're not stuck in, you've got to pick one compute approach for all your consumers. We can actually segment that up and say, for the BI usage, we're going to right size this. For data science, it's a little different. We're going to right size that. And then we're really using it for exactly its purpose and getting the best out of it.
Yeah, I mean, and I love that idea of just starting small, and you can't do. These are just things that you couldn't do in the past. You couldn't just do a tiny experiment and then allow it to grow.
We got burnt. If we did, we got burnt. I learned a long time ago, because you start these projects and you don't know how big the bread box is going to be, and you're sensitive to a client's budget and cost, and long time ago, I would let them kind of say, we're really trying to figure out the cost here. Can we start small? That was always, I learned very quickly, that's a kiss of death.
Why?
Because you build up your development environment, and all of a sudden you're okay, now let's expand this. Well, we bought you hardware, we can't get you any more. You know, we thought it was just going to be this. You know, you said we could start with this. Well, now we need bigger. Whoa, we don't have budget for that bigger size.
Yeah, but there are some changes that certainly make some things possible that we couldn't do before. So the whole idea of containers and Kubernetes and Docker, the advent of that ability to be able to spin up VMs on a local machine to experiment and do some things, certainly have changed dramatically the things that we can do. If you look at Raspberry Pi and the ability of you know, sort of chaining some Raspberry Pis together to do some data science exercises is certainly pretty amazing. I think the other big change, and this is again both cloud and on-prem, is our ability to do computations, numerical computations using GPU technology is dramatically changing the conversation of the world of the possible. So we hear about Bitcoin, we hear about sort of the things that are happening in virtual currency and miners and things of that nature. But again, if you look at NVIDIA as a company, you see those graphic cards are no longer being used just for kids doing gaming or adults doing gaming. I mean, everybody does gaming these days. But it's changing dramatically. So if you look in the marketplace today, why is PS5, why is Sony struggling to get devices in the marketplace? You know, there's a shortage of components, and a lot of it is because of certainly cryptocurrency work, but it's also partially because now GPUs are available as per hour. Yeah, you can get GPU power per hour, and so it's dramatically changing things today.
So, what about the integration costs? So we've done a lot of discussion about the actual the data warehouse, the data platform, stuff like that. What about the integration architecture? You know, are there surprise costs there? What's changed between the old and the new? And I realize that, you know, the server stuff is going to probably remain all the same, but, you know, what are some things that people aren't cluing into a lot there?
The big change, and I think we've been seeing this and have been adopting it maybe for 5-6 years now, but the big change is it used to be quite expensive for us to do change data capture off of databases.
Yeah.
So there was one main tool that worked around Oracle technology that gave us ability to do change data capture. And so the big dramatic change for us in our reference architecture, but also in the cost of services and work that's involved in getting changes off of databases, whether they be, you know, micro batch changes or even real-time changes. I think that's a big change. And that in itself has also driven a change in how we approach ETL, or as we do today, ELT.
Mm. Yeah, and that the percentage that represents these you know, these change data capture tools, it's quite a bit less than what we used to pay for, say, a full-blown ETL tool, right?
It depends on what it is.
The magic answer for every consultant.
Yeah, because you know, change data capture.
So if your source is SAP, if you source, you know, if you're sourcing some large complex sources, certainly there's a premium to be paid because of the complexity and perhaps under the covers some of the licenses that have to be paid to vendors. But again, I think the focus is. We used to write code. We used to spend weeks, and if not months, dealing with how do we process changes coming off of a database into something that we can consume. That work is now relegated to a tool that is configuration driven rather than development driven, and it's a big change to the way we operate this. So we may have talked about the Intricity data factory. If you think about, and again, I'll refer to your video, Jared, on data as plastic. It's a really good one that talks about data as part of, as a raw material coming into a factory. If you think about CDC, instead of us instead of us, you know, melting down plastic and having our own facility to process plastic, we are buying pellets. We are buying raw materials that don't require an additional processing step. And so when we have CDC tools, it's very much like that. Instead of buying a raw materials from which we will make plastic or data, we're getting data. And so we know that we've got deltas that are already rolling in. And then when you bring it into a cloud warehouse technology like Snowflake, there are tricks we use to make sure that we could pick up those changes. And so again, it dramatically, the question is cost. That component alone changes the cost structure dramatically.
Now, has any of this affected downstream business intelligence costs? So I'm trying to segregate this here, the back end from the front end. Has much changed there? I mean, it just seems like it's still named users. Most of the licensing models appear to be the same. Is it just basically the same?
So on the BI side, and there are still pieces before you get to BI that I think have cost drivers. The BI
let's
side.
talk about those, but yeah.
Okay. The BI side, I do think pricing models have changed. If you look, Power BI is a disruptor. The big vendors that we normally would incorporate into the BI stack have not necessarily changed dramatically in terms of pricing. But you have things like ThoughtSpot and Looker and some open source products that are doing quite well. The Apache Superset project and the commercial edition of it with Max, I think is very, very exciting in terms of the direction that that's going in. But if you think about, again, cost, we used to write code to do change data capture. What's the one thing we know is constant? It's change. And so when the sources change, what do we as consultants or what do we as employees of a company have to do? We have to deal with that change. And the amount of churn and the amount of complexity that lives in that CDC pipeline before a tool comes in is quite substantial, because Salesforce will change, SAP will change, Dynamics CRM will change. And so those are really difficult pieces of change to deal with.
So what are some of the pieces in between? So we got the warehouse, the cost of the warehouse, we got the cost of the CDC tool to keep the data replicated. You got your BI layer. What am I missing?
Well, and with the cloud, we've split the costs, at least on the warehouse side, which is storage and compute.
That's true, yeah.
So now we're talking, what is our storage footprint and what is our cost to maintain that storage, and what is our compute cost? So, and that's actually huge because before those were all blended together. And one of the challenges that we used to have, and cost-wise, is this is so very common, we would run into a situation where we would need either more compute or more storage, but to grow those, we had to kind of grow them in tandem.
Yeah.
And so we would get off balance. We'd have, more storage and have to bring up compute to accommodate that, or vice versa. And the other thing you asked about, what else is the new costs, or what are costs that we maybe didn't have a few years back, is organizations are starting to bring in a lot of new data that they never brought in before.
That's true.
Take IoT data, for example. All of a sudden now people are getting feeds from IoT. They're getting feeds from third parties. We're getting sentiment data from all these Twitter and blah 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 blah. So all of a sudden, other data sources that can be very huge and voluminous, we are having to bring those and deal with those. So the landscape is constantly changing. If you think about it, as people are starting to become more mature about how to use data, it is becoming more and more important in an organization, and more data brought into a single place that can be used holistically is a big driver. So, you think about old data warehouses, they were super siloed. We would typically say, all right, here's a financial data warehouse, and that's all we dealt with was finance, or here's a sales, or here's a CRM focused data warehouse. And we really rarely intertwined them. Partially was from hardware issues, because who was paying for it, and we'd silo those. And trying to bring them together all of a sudden got really expensive. Bring in Teradata and drop $5-10 million on hardware. or Netezza, you know, now we
Yeah.
can say we can bring all the data together without incurring some of those huge hardware costs that in the past we would bear. So it's the paradigm's changing. We're bringing in more data than we ever did before. An organization's data footprint is growing, like
we may have also,
like you mentioned, Glenn, I mean, the data that's available is growing like crazy. I mean, that a number of years ago, we didn't have all that IoT data.
Right.
We didn't have, I mean, you take about, I talked, I think last week about one of the clients that I'd worked with in the convenience store industry.
Mm-hmm.
You think about historically, what types of reporting were they doing? Very, very little. Basic types of gathering basic types of information to know what products they were, they needed to order from their supplier. Now we've got the data coming from the coolers, all the IoT information from the coolers are reporting, how cold the beer is being stored at. There's information about how people are moving around the store, if they're coming from the gas tanks outside and then coming inside. I mean, there's just the amount of data that's available is exploding. And so, and like Glenn said, now that people know how to use that,
and the
or
trend
learning
now,
how to use it.
The trend now is to have those in a centralized exchange. So Snowflake came out with their data exchange, which was pretty sure they were the first to ever do anything like that. But everybody's like, trying to find their own way to do that same thing. But that is actually, it's a very low friction cost, but it is a cost nonetheless to add more enrichment data.
Right. I mean, so there's two things. I think you have third-party data that is being more pervasively used. I mean, everybody's been using some form of third-party data from their vendors or from their customers, but now we're starting to get, all kinds of other third-party data that's being able to be brought in and used for our analytics. Weather data, for example, simple one. Now I can bring weather into this. I can bring market costs into it. I can bring benchmark data in.
Location.
And location data, and I've done some work where we were looking at buying big blocks of cell phone positional understanding. So we could say, what types of customers from a cohort point of view do we know about people that have driven into my parking lot with their cell phone on? I mean, that sounds a little bit crazy, a little bit Big Brother, but definitely some of those types of analytics are being done for the big box stores and things like that. We're trying to understand
foot traffic. That tells you foot traffic. That tells you sort of what's happening, who's walking in and who's walking by. All of that beacon data that's being captured as well.
All right, so let's talk negotiation when you're going into these things, because a big chunk of the cost of what you pay for your environment is what you negotiated to pay.
Exactly.
So, and these environments are, you walk into any negotiation, you're basically walking into a prearranged awareness that both parties are lying to each other. Because, you don't go to a car dealer and say, well, this is how much money I have in my bank account. And he doesn't go, well, this is how low I can get my car to be sold. Well,
I think, Jared, I think it's gotten easier in many ways, because when you're paying, so Snowflake, for example, you're paying per credit, and those are pretty stable. You know what you're paying for storage, because essentially it's a pass through, so you could validate. One of the reasons many years ago we adopted a posture of being a trusted advisor rather than somebody who gets compensated for making recommendations is that we sometimes have almost a fiduciary type duty to say, we want to size this properly. We want to make sure that this is done right. But I think this is where it gets easier as well, because you can purchase what you need today and then scale up from there. You can plan for maybe 10% or 20% headroom in terms of what you think, but you don't necessarily need to buy. I think the things that we used to say is, you're not buying it for Easter Sunday. You have the ability to sort of buy exactly what you need for now.
It's the old adage of building the cathedral for Easter Sunday. Nobody's there the rest of the whole year, but on Easter Sunday it's full.
Yep.
Versus in the past, at least, the perception of sales that I have, again, I started sales when I was in New York City. It just seemed like it was like a let's just see how much I can get out of this person. It costs us almost nothing to produce the product, but I can get a 10,000% return on it.
The magic of software sales. But I think right now the number of variables are much easier to manage, because think about it. So let's talk, since we've been talking this whole session about Snowflake. There are really two variables you need to manage to. Essentially, what is your storage plan? How much data do you need to store, and how many compute hours do you estimate you will need? And that we can look at our existing platforms and say, this is probably what we have. I think the hidden cost, and this is the piece that many times is missing, and we surface it as part of our engagements, is what's the cost of proper data engineering? Because a lot of times you have hardware and bigger hardware to compensate for poorly engineered solutions. And so I think that's another big cost in terms of optimization. A lot of times folks don't realize the things that you can do with the SQL engine, and when you have JavaScript as part of that engine. So there are conversations even that took place this week where there are really great opportunities to leverage. You and I were talking about the customer preference center and volumetrics of data that we're passing through there, and doing that in a way that it scales beautifully and elastically. But that didn't happen because we're running on Snowflake. It happened because we knew how to properly engineer the data science part, the data model part. I think that's the part that a lot of times is missing. That's the secret sauce, if you will, in managing the costs.
Yeah, this story, it reminded me of a story where there was all this press about and I won't mention any names, but there was all this press about a Snowflake partner that had closed it, or that had actually booked $1 million worth of compute in like a week. And as you got into the nitty gritty of what was going on, is they were like loading in serial, and just the worst kinds of no-nos that you would do as an implementer, that and with full bore compute just going out the window. I mean, just all of these kinds of bad things. So I think about that probably the biggest surprise costs are the ones where your engineering is really bad, and you end up making up for it in the form of just raw compute.
Right.
Yep.
Take for example,
Jared, it happens every single day. I think that's one of the challenges a lot of times. And you talked earlier about sort of the ability to do an analytics and understand, what the queries that are running, and profile some of them and get some statistics so that you can look and see if there are opportunities to optimize. I think the other area, and certainly the video series that you curate addresses, is I think there is a lost art of understanding what modeling is, because modeling is such an overused term. Just having a data structure doesn't mean that there is an appropriate data model for the use case that's in place. And so again, that's another big cost. You talked about the vendors and vendor negotiations and some transparency in the vendor process. I do think it's a little bit a game of poker. You've got procurement organizations that are looking to spend less, which is their job. You've got the vendor who's looking to get as much value as close to the retail price as possible. But I think, again, if you look at these things holistically, the other big thing is how much technology. So another part of that negotiation is, how do you onboard all of the skills? How do you bring people into the organization that can support it? We see at Intricity a lot of reference architecture that has, it's almost like a kitchen sink model where, this technology is cool for some other use cases, but we've got it as part of this project. And so that's a tough road to toe sometimes for us, because, you know, it is sexy stuff, maybe for a different type of application, but in analytics, it may not necessarily apply. So a lot of times cost goes up because we're complexifying simplicity.
Right.
Yeah, and
Absolutely.
that reminds me of scenarios where, you know, we'll get asked to participate in a sales cycle. In other words, a series of vendors has sort of surrounded a client, and they want us to be the implementer and whatnot. And I sometimes, you know, sometimes you'll see the stack of technologies that have surrounded the client, and you know, you can see that there's a potential cost train wreck about to happen with this client, and this is where it's, you know, there's definitely bad decisions that can be made related to a bad mix of technologies.
Oh, yes.
In the cloud.
Well, it's back to your video on Beware the BI demo, which applies not just to BI, but many different technologies. And a lot of times, you know, a technology vendor is trying to show all the different use cases that you could use their technology for. And I always kind of equate it to, I can take a crescent wrench and I can do lots of things like hammer and, you know, use it for, you know, a level and all these different things. And yes, it might work, but it is definitely the wrong tool. And the cost to use the wrong tool can be very expensive. I've both experiencing this firsthand in being, you know, forced to use a certain tool that was just the wrong tool for what we needed to do. And our cost for implementation was just huge because it just was the wrong tool, and we were having to work around its lack of abilities for our use case. And so this is where, you know, and I say this to everybody that asks me about it, I say,
give you a word of counsel.
Yeah, I'll give you a word of counsel here. Before, you know, get the hands up, two hands, is before you land on a technology decision, let's review what it is that you need to get done. Let's put technology aside just for a second. Let's look at what the big picture is. How, you know, how important is this to you? You know, you always say, if we're doing something and it's not critical or super important to you, I don't need to buy the super fancy, you know, tool. The other side of that's also true. If I have a real criticality here and we buy, you know, we used to say in Portuguese, Zé de Esquinas, Joe's corner, you know, piece of technology that is not, you know, scaled for what we want to do, we'll pay the price on performance or stability or things like that. So making sure that we look at the use case and saying, let's get the right technology and do that. I often see this problem. Here's a real common, and we see this with a lot of CDC not being used, is people will say, well, I don't want to use a CDC tool because I could build this. You say,
it doesn't look, it looks straightforward to do until you actually have to execute on it.
Do it and maintain it, and it has to run every day, and you know, all of the little things that you probably didn't think about making sure it ran every day, and we got the right data, and we're not missing data, or we're not overlapping data, we're not duplicating data, all those fun things is a piece of work, and that's a lot of work can go into that. And so in the world of data warehousing, getting the right tools for what it is we're trying to accomplish and making that investment is critical. You know, and the cost of the tool is not always a you know, if I buy a more expensive tool, it's a better tool. Not always. If it's the wrong tool for what you're using, it doesn't matter how much it costs.
It's just even more money. That's all it is.
It's even more money, right?
More pain. So we've talked a lot of our discussion has been around sort of the process of implementing. I want to get into the maintenance side of it a little bit. What are some of the costs that start creeping up inside of these, you know, these cloud data platforms as we're maintaining them, that you start seeing? And we've touched on a little bit, but I want to kind of get into that. You know, some of the access control costs that can occur there, where we don't have, users are unable to use it, and those kinds of things.
it goes to the term that we use when we're working with clients. We talk about hardening and hardening the platform for production. Part of that hardening effort is around making sure that, you know, a couple things come together. One, the process of daily loading of data is very mature. It works every day. It's very idempotent processes, meaning that if something fails to do its job, that our process to fix it or to rectify it is not to go and undo a bunch of things, but literally run it again. Okay, so we design the process as we harden it to be very idempotent, run it again if it fails. The other side of that is also making sure that we've got the security and access controls properly set up and defined so that we don't have the problem of, well, we've got the data in there, but we have such a problem of maintaining user access, and either we've granted too much access to it, and now we've got concerns about that, or we've granted too little and people can't get in, and they're always calling help desk saying, hey, I tried to run this report and it says I can't look at this data, and why is this the case? And so some of the costs that can really come to bear after we've implemented things is, if we really haven't hardened the process, you can have a lot of daily, literally daily maintenance to, you know, make it work every day, and a lot of time spent from people having to babysit the process. The other side of that can be just, you know, running around trying to grant access and maintain access to your users who are consuming it. So as we talk about, you know, there's a cost to harden, there certainly is, but having that cost done right up front and done well pays off. And you know, I always love systems where people say, wow, we don't do much to keep it running every day. It just runs, you know, it runs and runs and runs and runs and runs. And if there's a problem, we run it again and it's back on track. And so, you know, we don't have to have people that have alarms that go off at 4 in the morning just to get up and hit a couple buttons to say, is it okay? Is it okay? I've lived that. You know, I used to, when I was CIO, we had a process that was very problematic, came off a AS400, and it was very sensitive to all kinds of different issues. And so I literally we used to have our teams, different people, different weeks, get up at 3 in the morning and do a check. Is everything okay? Do we have to restart something? Do we have to, you know, go through some, and those type of things are no fun for anybody. So those costs are costs not only in time and energy, but just frustration costs. You know, you want to have a system that you feel is stable. When your system is fragile, that's a cost.
Now, we only have a few more minutes left, and one cost we have not talked about is the conversion costs. So, you know, unless a company is just starting from zero, you know, there is something of a conversion cost, whether it's, you know, taking an old system and going forward, or loading data from application systems. But I want to specifically talk to, you know, I'm company cost. A, I have an existing data warehouse or a data, you know, data warehouse appliance. I have maybe a Hadoop system or what have you. Those conversion costs, you know, what are some of the things that they need to be thinking about in relation to that conversion?
Well, doing conversions is an interesting exercise. One of the things we always have to think about is two costs. One, what is the cost to actually convert it? Yeah. But what is the cost, you know, for how long it takes to have that up and running? So some organizations are on old systems that are dying or are out of maintenance and they can't get new maintenance, or they have to pay an arm and a leg for maintenance. And so if those are the cases, then our focus is what is the path to quickly get you off, okay? Yeah. And so that can be one approach, and then maybe there's a secondary approach that maybe improves some things and whatnot. What we have to really watch for is that what is the right fit for an organization? Is it to expedite getting off of a platform? Is it to change up problematic processes that existed in loading the data on the previous platform, and let's fix those coming into it? And so there's some really important planning that needs to happen up front to reduce long-term costs and overinflated costs.
I've noticed too that and again, the excitement is, hey, I have a new data platform. There's a lot of excitement with that, but they'll totally forget about the fact that they've got to convert their integration processes.
Yes. the
So
integration
they
process.
have these integration tools. They haven't even, they don't give it a second thought until, well down the line. They're like, oh my gosh, we've got to repoint all of this integration processing to now point to our target data platform in the cloud.
And this is where using the right tools to help automate that, so that we want to make migrations such that we don't make so many changes in the migration that we upset the apple cart, that we can get to a done state fast. Okay, especially on those systems where we've got end of life of system that is, imminent out there. Using a lot of these tools to help us do mass conversion of either ETL code or data ingestion processes or things like that can be particularly valuable, even though there's a cost for those. Sometimes the fact that we can move much faster and more consistent is worth the cost of those.
I think another one that is really not talked about a lot, but is a huge effort is the data testing.
Oh, yes.
So you do the code conversion testing and you validate that the code compiles on the target platform. But now you've got to actually validate that the data on the target platform matches the data on the source platform. And for all of its permutations, all of the stored procedures, every sort of use case you could think of has to match. And
those can be extensive processes, where we can automate those. That's the preferred approach. We go through a lot around how do we set a gold standard for accuracy. So what is our test cases? And so as much as we can have organizations work with us to create those kind of gold standards, this is if the data that's being moved over matches this, we know we've done it right. If we can take the time to build and define those, then migration becomes less painful on the testing side, where we're saying, well, how do we test this? And how do we know if we're right? Especially if we've made some changes so that, we can't compare old system to new system because there are some changes to it. So that goes to the planning up front is, how we're going to test this thing.
And I would inject there that you don't want to push too many new changes to your target platform. There's just a temptation, right? And it's totally well-founded. Yeah, I want to take advantage of, rebuilding or restructuring some of these things as we move over. Well, the problem is you've got to test this. And so you want to remove as many changes as possible that are really just down to the syntax that is required to run it, because otherwise, if you change too much, it's difficult for you to backtrack on, well, where are we off, because we've changed so many little pieces here. It's too difficult to track. So often what you want to do is, get your syntactical conversion done, show that it's successful, and then start doing changes. And this is
right. And this is not an easy piece of work to do, because it's a balancing technical debt. Moving off one platform and having a dependency on certain pieces that you'd want to sunset, but we can't because we're afraid to make too many changes. So now we're carrying technical debt, and sometimes that's a good plan as long as we have a plan to reduce that technical debt. The other side of that is make too many changes, and now we run the risk that we're just not right anymore, and then how to get back to right.
So now that we're coming close to the end, I think it's probably safe to say that all of this is only like $20,000, right? I do get a kick sometimes out of.
What's the time period for that spend?
Yeah,
exactly.
$20,000 per.
Jared, you can do a lot with $20,000 these days
right.
in terms of infrastructure, because again, depending on the problem you're trying to solve, $20,000 may be a really, a Rolls-Royce budget here for the problem you're trying to resolve. But again, for large enterprise, I think simplifying complexity is one of the key things that we find is important to manage costs, because resource costs are where most of the challenges are. It's the turnover of knowledge, it's the turnover of people. Those are the things to worry about. And so as we swim in these waters, that's the one thing that I think is really important is follow rule number one at Intricity, which is don't move data, or stated more correctly, move data as few times as possible. I think there's a desire to move data between variety of tools and technologies because they may be a good fit for one specific use case. Look for opportunities, look to see where you're moving data multiple times, and really question whether that's required.
Yep.
All right, folks, that wraps us up. Thank you, Arkady. Thanks, Glenn. Thanks, Rich. And we'll continue on with our weekend. And
all right,
everyone.
Meet you all later.
thanks.
Bye-bye.
You all have an excellent day.
All right, bye.